this is just covering the work we did in class yesterday, so on Monday, but I thought I'd just put the video up just so you've got the information there and to help you work through exercise 12A, hopefully today that you're working on that. So yesterday we spoke about the inverse matrix. So when we talk in maths, we have inverse operations. Okay, so if we have something like 5 times m, then the opposite of 5 times is divided by 5, which is the same as multiplying by 5 to the power of -1. Okay, so if we went 5 times 5 to the power of -1, we're going to get that's equal to 1. Similarly with matrices, if we have a matrix A, it has to be a square matrix. Okay, it's really important, and it can only work to square matrices. If we have a square matrix A, then we can find a matrix A to the power of -1, so that if we go A times A to the power of -1, it equals the identity matrix. Okay, so the identity matrix I is the matrix 1, 0, 0, 1. If we go A to the power of -1 times A, so the order is not important, it equals I as well. Okay, and this matrix acts very similarly to the number 1. Okay, if we multiply a matrix by this, we get the same answer back. Okay, so whatever matrix we multiply by the identity matrix, we get the same answer back. Okay, so that's the first. That's basically what an inverse matrix is. Okay, you probably don't need to copy these notes into your bound reference. The notes we made in class yesterday are probably ample for your bound reference. This is just extra support. But if you find something I write down is useful, put it in your bound reference by all means. Okay, now in order to work out the inverse, we need to work out the determinant of a matrix. Okay, and we're only going to do this for 2 by 2 matrices. We'll let our CAS calculator do it for 3 by 3, 4 by 4, and anything that's bigger, possibly not bigger than that anyway. So we've got a matrix, and we're just going to give it a general matrix. So we're going to call it A, B, C, D. A, B, C, D are all numbers. They may be they can be different, or they can be the same. Okay. What happens to work out the determinant? Now notice this is a matrix. It's got square brackets. This is the determinant. It's just got straight lines instead of square brackets. So the determinant of A, which we write as det A, is just simply A times D minus B times C. Okay, so if we've got an example, if we had the matrix, I'll just make one up, 5, so this will be, it won't be a nice neat answer, but that's fine. So 5, 7, 2 and 4, so that's our matrix. So A is 5, B is 7, C is 2 and D is 4, and we're going to call that matrix V. Then det determinant of B is going to be 5 times 4 minus 2 times 7, or 7 times 2. I should have written be consistent. Okay, A times D minus B times C, which is just going to be 20 minus 14, and the determinant of B is 6. Okay, that's all there is for working out the determinant. Okay, if there's anything you need to copy here, just pause the video and copy it down. If you want to copy that example, by all means do that. Okay, now we've got a rule where we to find the inverse of a 2 by 2 matrix. As I said, anything bigger you'll just use your CAS calculator. And what we're going to do, we have to go that if A is the matrix A, B, C, D, then A to the minus 1 is 1 over determinant of A. So pretty much what that means is we're going to divide all the numbers in the matrix by the determinant of A. And we're also going to do a couple of things. So we're going to switch these two numbers around. So we switch the A and the D, and the B and the C, their sign changes to a negative number. They stay in the same place, but their sign changes. So if we have the matrix two, 2, 3, 4, we're going to call that matrix B, then the determinant of B is going to be 2 times 3, and you just dip in your head. 2 times 3 minus 2 times, let's get it right, sorry, no, right. Okay, AD, 2 times 4 minus 2 times 3, A times D minus B times C, which is just going to be 8 minus 6, which is 2. So B to the power of minus 1 is going to be 1 over 2, okay, 1 over the determinant, and then we swap these two numbers around, so we put a 4 there and a 2 there. We change the sign of these two numbers, negative 2, negative 3, and then we're just going to expand the matrix. So we're just going to do this scalar multiplication. So we multiply everything in the matrix by a half. So 4 divided by 2 is going to be 2, negative 2 divided by 2 is negative 1, negative 3 divided by 2 is negative 1.5, and 2 divided by 2 is just positive 1. Okay, so that's the rule for finding the inverse of a 2 by 2 matrix. If you need to copy any of that down, once again just pause and copy it. Okay, now let's just go and have a look at our made up matrix. So we'll do one more example. So our made up matrix was the matrix 5, 7, 2, 4. I'm going to call that matrix M, and if you can remember, the determinant of M was 6. So 5 times 4 is 20, 7 times 2 is 14, 20 minus 14 is 6. Okay, so M to the power of negative 1 is just going to be 1 over 6 times, we swap the 5 and the 4, change the sign of the 7 and the 2, and that's going to equal 4 over 6, negative 7 over 6, negative 2 over 6, and 5 over 6. If we did that with decimals, they're going to be recurring decimals because that's divided by 6. We could neaten it up. We could call it 2 over 3, negative 7 over 6, negative 1/3, and 5/6. Or we could use the decimals. Now what I want you to do is have a look at how to use the CAS on page 419 of your book. So CAS on page 419. Have a go at doing that, follow the steps. They do an example with a 3x3 matrix. Follow the steps and note the use of the word exact. The use of the word exact is when you've got a matrix like this, okay, and it will give us an answer in fractions as opposed to decimals. Okay, that's the only difference. And then you're ready to go with exercise 12a on page 421 of your text, and just have a go working through all those questions. Note that you can use a calculator for question 2, or you can have a go at doing them by hand. Maybe do a bit of a mix is my suggestion, and you're going to use a calculator for question 4. Okay, you'll get some practice doing them by hand with question 3. Have a go at those, and if you've got any questions, remember I'm on Teams at any time and you can come and just ask me a question. Thank you.